Why don't we get started? Good morning, everybody. Thank you so much for joining us for our Friday series, Coffee with a County Forester. Today we have Ali Kosiba, who is Coffee with a Climate Change Forester, working with our Vermont Department of Forestry. She will share with us a little bit about her new job. This job has just been created, and it's going to be interesting to see where it goes and where she takes it, and what kind of questions we have to ask her as our climate change forester. So Vermont Coverts and Vermont Woodlands Association is happy to bring you these events. I do want to note that next week, our Coffee with the County Forester is actually going to occur at 1 o'clock instead of the 9 a.m. time with Ethan Tapper and, Morse. Sue Morse. Thank you, Sue Morse. That's going to be at 1, and we're going to be talking about old growth forests. So stay tuned for that. And I'm going to turn it over to Ali for a second. I just asked that you all mute yourselves and use the chat room to ask any questions, and I will facilitate asking those questions to Ali, and we can get some of our questions answered about what it means to have a forest in Vermont in addressing climate change. So Ali, I'm going to turn it over to you if you tell us a little bit about yourself, a little bit about the position, and anything else you want us to know before we bring in the questions.
Sure. Thanks, Lisa. Yeah, I'm very happy to be here. I should have, Lisa, and no fault of your own, I should have given you a primer on how to pronounce my last name. Everyone mispronounces it, but it's Ali Kosiba. And so, yeah, I'm the new climate forester for Forest Parks and Rec. It's a brand new position. It was supported by an organization called American Forests, which is based out of DC, but it's this national organization that does a lot in promoting forests, forest cover, forest conservation, good stewardship, good forestry of the land. They're part of the 1 Trillion Trees project you might have heard, which is really attempting to really do some reforestation and planting in a lot of places to increase tree cover and carbon storage. So they're a really interesting organization. If you haven't heard of them, check them out. So this position, I've been in it for, let's see, I think I came on at the end of April, so fairly short amount of time, but I've been in Vermont for 10 years now, I think, working in Vermont's forests. So I came as a grad student at UVM, working with the U.S. Forest Service, Dr. Paul Schauberg, who does a lot of tree physiology work. And I really was looking at how trees are responding to environmental change. So really, when I came in, pollution, acid rain was a really big issue that we were looking at, particularly for the red spruce tree, which has been very severely impacted by acid rain. And it's kind of this canary in the coal mine for looking at pollution impacts to ecosystems. So it's a really, very long story that began in the 60s. Lots of folks researching it, a lot of money, federal money that went into looking in this. It's a pretty amazing story because all these researchers found out independently, groups looked into these impacts and actually figured out what the cause was. So the mechanistic cause was acid rain leaches calcium, actually, and the calcium is needed for these trees to respond to stress. And so what we were seeing is red spruce were dying, and I came in to study that and then actually discovered that the red spruce trees were doing excellent. So I did use dendrochronology, which actually I have show you what a little tree core looks like. I don't know if that's even visible, but basically you take tree cores out of a tree and you can measure the annual growth and convert that into carbon as a metric of the physiology of those trees and how well they're responding to environmental change, and found out that red spruce were growing amazingly. We didn't expect that. We thought, oh, these trees have been impacted for decades. So it's kind of a cool story. Showed how, science finding an issue in our ecosystem, researching it, figuring out why it's happening, and then actually scientists, including from Vermont, went and testified about this issue, and we had amendments to the Clean Air Act. Took a while for those amendments to really cause a positive effect in our ecosystem. They happened in the 90s, and we didn't really see positive effects till a couple, a decade or two later, but it is a success story about how we can actually reverse some of the negative impacts we've had. And, we didn't know during the Industrial Revolution that acid rain would cause these problems, but then we found out they were causing these problems and we did something about it. And so I think there's a lot of parallels there with the climate change crisis of, yes, we maybe didn't realize a lot of these things were happening when they were happening in the last number of decades, but now we know. What can we do to reverse some of the damage, or at least slow down some of the damage that we're causing? So that was kind of my research background. And I also researched other trees in the region. So sugar maple, yellow birch, balsam fir, trying to think, red maple, lots of American chestnut I've done work on. So I've kind of done work on a slew of species in the region for my graduate work. And then I've been in the area for a while. I actually taught a couple classes in the forestry department, including very amazing class, dendrology, which is very close to my heart. I'm a big tree nerd, as it will come out as you get to know me. But so I got to teach dendrology, and then a natural resources course at UVM, which was really fun to be working with students. And then I worked for an organization called the Forest Ecosystem Monitoring Cooperative, which is a great nonprofit that's based at UVM. They're federally funded, but really just do work to enhance the information we have about forest ecosystems in the Northeast region. So they produce a great conference that happens in December, which I really encourage you all to attend if it happens, or attend virtually if that's the way it goes. It's pretty reasonable to go to, and pretty approachable for a wide range of audiences. Covers all aspects of forest ecosystems, from amphibians that live, in the leaf litter, to trees, to air, and everything in between. And they also produce a lot of great, useful tools, online tools. If we have time, I'll showcase a couple of tools. One that comes from the FEMC that are really trying to make information and data more accessible to a wide range of audiences. So that's kind of, my background in a very, very close nutshell. And so I came here to FPR to work as a climate forester, and really why this position was created is FPR has a great forest health group that focus on pests and pathogens and impacts to our forest from that standpoint. But really, when Sandy Wilmot retired, it wasn't anybody that kind of carried the torch in looking at climate change impacts to our forests. And really, I see my role a lot is synthesizing the science. Science is constantly changing, updating what we know about impacts to our forests, what sort of changes we're actually seeing on the ground. And so how can we get that information out to a range of audiences, to foresters, to landowners, to folks that have easements? How does that information help them be better stewards of their forests? But certainly also my role will be helping with advising legislation. There is a Global Warming Solutions Act that just passed the House. And so this is a little bit of a new territory for me, is getting into helping make sure the science is sound and that forests are being considered in legislation. And then also helping provide information for foresters and landowners to actually do management. So how can we be really intentional with incorporating climate change science into management? So that may be that, on state lands, on private lands, what sort of adaptation management strategies can we use? Creativity, I think, is going to be a big part of us moving forward in the climate change crisis. We don't know the answers. We can do our best to forecast and predict, but we really, there's a lot of unknowns, and I think a big part of this in any crisis, in COVID, in a lot of parallel examples, like us all coming together, sharing knowledge, being collaborative, is going to be the key to us actually making some meaningful change here. So that's part of, I see my role too, is facilitating that, getting people, different groups talking, how can we share information and not reinventing the wheel each time. So there's a lot of great resources out there, a lot of great groups that are thinking about this stuff. And I have, some resources I can share, or if there are questions come up related to those adaptation management strategies, I can share some great resources there are out there. So just started the position, so you'll be seeing more of me. I'll be producing a lot of products to put on the website, handouts, different kind of interactive ways to understand this information. So, now and in the future, please email me if you have questions or things that you think of. I want to create a good dialogue and understanding what people are seeing in the woods, what their needs are, where there's maybe gaps in our understanding and climate change effects on forests. And yeah, so it's a lot of work. And so, like I said, I'll be relying on getting everyone together and how can we move forward as a community on this. So,
that's great. And this is a nice start to that. So I did put Allie's email in the chat box.
Oh, thanks.
So you can find that in there if you want to email her directly at the end of this. Allie, let me ask you a question. And anybody out there has questions, go ahead and type them in the chat box for me. But I'm going to start it off with just sort of wondering, what do you see Vermont's forests changing? Like, what are our concerns and how are we going to address those? Or what are we doing now?
Right. So the biggest concerns with our forests, well, our climate is changing. It's already changed. It will continue to change, and the change might become more rapid, right? As we continually increase the amount of CO2 in our atmosphere, it stays there for a really long time and builds up, and so we can get kind of an increasing rate of change. But we are seeing change, as you probably see those alerts from NOAA of like, we had the global warmest May on record, and every one of the last 10 years has been record setting, and certainly we have variability. Like, we had a very cool spring here in Vermont, but if you look at the global average, it's above the long-term norm. So we're seeing these changes right now. Those changes are not far from what we've been used to. What is the climate envelope is kind of like the technical term, like what are the range of temperatures that we have seen in the past? What is the range of precipitation that we've seen in the past? Like, what are what are those patterns? Because that's what the trees here are adapted to and are used to living in. And so we haven't really seen huge changes outside what trees can tolerate. In fact, some of these changes are going to be beneficial to trees, right? Like, we've already seen, we have a longer growing season. Well, that's actually kind of good for our trees in the short term, because our climate here is, our trees are temperature limited. The biggest reason why they don't grow more is because we have cold temperatures that come in the fall and don't end till the spring. We have a pretty short growing season. It's kind of amazing if you think about how big our trees get, how lush our forests are, that growth happens in such a short window. It's pretty impressive. But so if that window lengthens by a week, 2 weeks, that can be okay for trees, and they can actually respond well. So we are seeing already some growth increases because of a lengthened growing season, warmer fall temperatures, especially for trees that don't lose their leaves in the fall. So, evergreen conifers. So larch is not included in that, the weirdo that it is, that it loses its needles in the fall. But all our conifers we have here keep their needles year round, and they can actually photosynthesize pretty well in the fall, as long as there's a key here is that there's moisture, right? So all these processes that trees need, like moisture, is really, really important. And so I think that even though we call it, global warming, the temperatures are changing. That's like the mechanism that's happening with the greenhouse effect. But really what the impacts are going to be are the other things that temperature change causes. So causing changes in rainfall and how, when that rainfall happens in the summer. So I think those are going to be some of the more impactful changes we see. So we've already kind of seen it. We got really heavy rainfall events, like a few inches. Then we might have, a month of drought. We can get a lot of rain. So it's less consistent rain. And so that can be okay for like the big trees. The big trees can have deep roots. They can kind of pull up water. It's kind of amazing, actually. Trees have this ability to pull up deep water and cycle it in the forest. But you can imagine a small seedling or sapling that has shallow roots. These kind of periodic changes in precipitation can actually be pretty problematic for them. So I think that's going to be a big thing. We're already seeing that more really heavy rainfalls that cause erosion, that are washing away like the leaf litter on the top of the soil that protects the roots. So that's going to be a big thing. And I think we need to already foresters and loggers are already managing for that. And I would encourage all landowners to be keeping an eye out for that, managing for that. If you got 2 inches, 3 inches, 5 inches of rain, where would it go on your property? How steep is your property? What are your soils like? Do you see, I mean, I've seen the last couple of years on my property, I'm, a little bit, we're kind of steep here on the side of Mount Mansfield State Forest. But we have these kind of channels that have popped up. They're not streams, but it's just because of these extreme rainfall events, they find the path of least resistance and then cause erosion. And so those are places that I target for, okay, I need to spread that water out, help it find other places to go so it can soak into the soil up high rather than just shooting down and causing lots of erosion and lots of problems. So that's certainly something to keep an eye out for now. And then these other things that can happen are, interactive effects. So we've seen this in southern New England with gypsy moth. They had really severe, gypsy moth really kind of has these cyclical patterns and hasn't really caused huge amounts of mortality over the years because there's like a fungus that actually will affect the gypsy moth caterpillars and kill them. So there's a little bit of a balance that happens. But they had a really dry season, and so the fungus really wasn't present, didn't have the right conditions, and so gypsy moth caterpillars and were just really prevalent, has caused widespread mortality of oaks. I mean, it's pretty incredible. If can't go there now, but in another time, if you can go to, especially eastern Massachusetts or like central, you go down these beautiful, country roads, huge oaks. I mean, equivalent to us with our maples on the side of the road, and they're all dead. I mean, massive red oaks and white oaks, and it's really, it's sad to see. It's also, a hazard issue to remove those trees. But really, the issue was that the gypsy moth caterpillars, and then having this drought effect that caused stress to the trees, but also limited that fungus that was expected to control the population. So you can kind of have these new novel conditions that we don't have an analog for because the conditions are just changing. And so I think those are things that we just have to keep an eye out for. It's hard to predict those types of interactions. But those are, that's why, sharing information, having things that we can keep an eye out for. Something I would like to create is sort of like a guide for landowners of like, what are key things to look out for in your forest? Like, what are like red flags or key indicators of change? I think that could be kind of helpful because there's a lot when you're out in your woods to look out for, but what would be kind of key things to keep an eye out for?
That's really great. I've always, when we walk trails, I've heard, Keith Thompson talk about, slow the water, sink the water, or spread the water, sink the water. But I've only really ever thought about it in relation to the trails, putting in water bars or getting it. I didn't really think of it in terms of these large water events that we've been seeing. So that's for me a new thing. So thank you. And maybe that's a new thing for some other people. So I'm going to read a few that popped into the chat box. One is just a little information from Jeff. The Global Warming Solutions Act is currently in the Vermont Natural Resources and Energy Committee and maybe even voted out of committee today. He's encouraging people to maybe talk or call or write their senators, particularly those in Addison who have Senator Bray because he's the chair of the committee. Can you tell us a little bit about this act and how it would help Vermont or what it means for us as citizens of Vermont?
Yes, and I will preface that this is a new part of like my repertoire is interpreting legislation, and so, you know, my science background, I hope that's part of this job, but this is the first time I've done this, so I will just disclaimer, but yes, so I am familiar with that, and working on identifying if there are things in that bill that are not considered in terms of forests and climate change, and what this does mean for forests. So basically, the Global Warming Solution Act is a binding agreement to reduce greenhouse gas emissions from the state, and also from energy that the state gets outside of state boundaries, right? So if we're getting, I think, you know, equivalent like energy from Hydro-Quebec, that is energy that Vermont is using, right? So that's that. And it's really to meet we are still, as a state of Vermont, we are part of the U.S. Climate Alliance, which is 25 states that are agreeing to meet the Paris Climate Accord. So U.S. pulled out of it, but there's a bunch of states that we all got together and we said, nope, we're going to hold this up, and we want to meet these reductions. And so it's pretty ambitious right now for our greenhouse gas reductions that we were trying to meet as a state. We're not quite there. I think we're like 13% higher than where we should be by 2020. So we're going to have to do a little bit more work. And so the point of this bill is that it would put more that the state would be responsible for meeting those requirements. So other states have done this, that they've put a mechanism in that people can really seek. They can sue the state. They can seek issue if those reductions are not met. And so part of this, the people that support that say this is needed to make sure it actually happens. Like if you don't have a consequence, sometimes it's hard. This is going to be hard to reduce our greenhouse gas emissions in the state. And so sometimes you need something that kind of puts your feet to the fire. There's other people, our governor is not super supportive of that. So we'll see how that part of the bill ends up fleshing out. I don't know details too much about that will get decided, but the basic fact is that this is a mandate to reduce greenhouse gas emissions over time. So how we do that is still up in the air. This bill would create a climate council that would then create a climate plan by, I think, next July 2021 by the latest. So that's another part of it, is a big portion of what would be done is not in the bill. It will be decided in this climate plan. But the council is, I think, 21 or 24 people. It's pretty big. It gets folks from within the government, outside the government, citizens. So I think it's really trying to get a wide swath of folks considered. And so there's a number of portions that relate to forests. Forests are really, as we all know, like incredible resources for us, and that they are doing this thing every day by capturing carbon dioxide and storing it into their wood. It's pretty amazing, and they make this great resource for us. They do all these awesome things. And so folks are finally realizing, okay, forests aren't just like pretty things to look at. They actually are doing this great service for us. So that is probably going to be a big portion of it, is what sort of, are we going to get it? Is there going to be a carbon market or carbon offset part of this? So that's basically offsetting if industry is trying to reduce their greenhouse gas emissions, can they offset some of those by buying carbon credits, essentially growth of a forest stand, to offset some of those costs, and how would that work? It's really nascent in our state. Maybe some of you know about a couple projects that are going on looking at carbon markets and carbon offsets, but the bill would probably have a part of that. Forests are recognized as being really important, which is great, and I will do my part to make sure that continues. My big thing is that we really need to, if we're serious about global warming and reducing our footprint here in Vermont, keeping forests as forests is number one. Like the amount of forests we have, that is the reason we have so much carbon storage. If we cut that forest in half, right now, our carbon sequestration we get from our forests, from our trees, is about half of our emissions in Vermont. So if we cut that forest in half, suddenly our carbon sequestration is only a quarter, right? So it's really easy to lose that great resource we have by just, having more, undefined development that is getting into these forests that are doing what we need our forests to be doing, which is taking in, storing carbon, producing this resource for us. So I think that's a huge part, and I'm hoping that maybe there'll be some funding in this bill to increase tree planting, so restoration in areas I think would be great, and potentially to preserve some more forests with easements, right? So that doesn't inhibit the forest management of those stands, but it inhibits that they could be developed and lost to other uses. So I'll stay tuned, keep up to date with the bill. We'll see where it goes. I mean, I think it's incredibly needed that we move forward as a state and have some sort of comprehensive plan. Right now, it seems like it's a little bit, everybody's doing a little bit, and we need to really have something.
Great. So I find that I'm glad you mentioned management, because that's one of the things, it's conversion from forest, not that we can't do management in it. And so that was really important. And it kind of leads into a question. I'm going to skip a little bit in the chat box. I promised to go back to those that I skipped. But Cheryl talked about feeling that one of the biggest threats, especially to interior forests and connectivity, is parcelization. And can you speak about what it causes with regard to interior species, invasive species, climate change? So we're still fighting that fragmentation, parcelization, and this has been something we've been talking about for years. So, what does that bill address it? What other things might be?
That's a great, I don't know that the bill, I don't think fragmentation is part of it, but I could be wrong. I don't think so. But certainly the value of forest cover, but right, that's kind of a different, you could have a whole bunch of fragmented forests and they would still store the same amount of carbon, but we all know they wouldn't have the same ecosystem value for other parts. So there is, bringing up fragmentation is certainly important. Parcelization is really the subdivision of a larger parcel. It doesn't actually mean that those are fragmented, but as soon as you start putting, especially when you put house like in the middle and create these kind of like a patchwork of the forest, that really does limit, from a wildlife standpoint, limits movement, but certainly from even a plant standpoint, if you think about seed dispersal, pollen dispersal for reproduction, that really is contingent on having connected forests. And also one thing that I really see as very important in our forests is having genetic diversity. So this doesn't, we talk about species diversity, which is certainly like one really good management technique to think about on your land, is having diversity in species and structure. And something you can't really see or measure very easily is the genetic diversity. And so this is kind of on a landscape scale, but keeping a range of locations where species exist, that we have kind of different adaptive capacities of that species. So sugar maple growing up in the Northeast Kingdom have lived in a climate that is different from Bennington, right? And so they are different genetic lineages. They're probably related, as that tree, as sugar maple kind of marched up after glaciation, removed the glaciers, they melted, but they'll be all, they'll have different adaptive capacities. So I think that's the key, that thinking about our state as a whole. And again, that's kind of a little bit my job, is thinking about this landscape scale issues that we have. So keeping a range of sites. We don't want to have a species limited to only one location and really has this bottleneck in genetic diversity. So yeah, fragmentation is certainly an issue. but it's really part and parcel to losing forest cover. I think is that is the biggest thing. And fragmentation kind of is something that often leads to a loss of forest cover. But you may all be aware of Fish and Wildlife Department here in Vermont has made the Vermont Conservation Design, which is a great tool and concept. You can look at it online on a web map viewer, and really identifies those core forests that we should keep intact for exactly what I'm talking about, of keeping, having corridors for species to migrate north if it gets a lot warmer, for having those kind of gradients in genetic diversity and adaptations. So that is something that we're thinking about, and how can we identify those little missing spots in between larger parcels for perhaps like a conservation easement that, again, would not curtail any management, because that is really great for maintaining the health of our forests, but would limit the development and the loss of those forests. So I think that is something that as a state we really need to be thinking about. Where we kind of hit the cusp of, we are losing forests now. It's hard to get an exact number on the amount of forests we're losing. I've been working on this actually to estimate the amount of forest loss we're having. It's anywhere from 1,500 acres a year to some other estimates I've looked at have been about 5,000 acres a year. You'd think it'd be, oh, we should just know how much forest we're losing. Well, it's quite difficult to actually do that. Now we have satellite technology, so we can do that a little bit better, but there's still a lot of issues with that. So we are losing forests as certain. The amount is a little uncertain, but I think it's something we really need to be concerned about, is where we're losing forest, what does that mean, and what is that forest getting turned into?
Great, thanks.
Mm-hmm.
All right, Maggie wants to know, are there any organizations in the Northeast that you're excited about collaborating with? She gave example of the regional effort on invasive species and climate change management at UMass.
Yep. Yeah, they're great. UMass is doing a lot of really great work. There's a lot of organizations that are thinking about this, doing work, and from different perspectives, right? From the landowner perspective, there's researchers. The UMass group is really research-based, that are doing scientific research to pull apart some of these questions and then provide that information in a hopefully digestible, useful way. The one big, and I can actually share this. I'll share my screen for a second, because I do want to show, if you're not aware of this organization, NIAX, show this website. And I can share, I can send these to Lisa to some websites. But NIAX is a great organization, the Northern Institute of Applied Climate Science, and they have a whole bunch of projects that will probably be of interest to folks here. And I'm working closely with them on a lot of this work. We're working on getting some more specific strategies for Vermont, and some more informational material. So they have adaptive silviculture for climate change. There's kind of some examples of different climate change forest management strategies. They're really looking into carbon, how to manage for carbon in your forest, like what are good practices if you want to increase the carbon content. There's a climate change resource center, and climate change response framework is one I'll click on, and you'll get some information. You can go to this project website, and this is really great. There's, so much information here that I cannot get into, but like I said, I can share this website and you can poke around. This is something that they do trainings actually for folks to understand impacts of climate change on forests, and how, and if in your woodlot, in your forest, how to think about what the risks are, how you might want to manage differently, thinking about in a climate change way. So they have things of like understanding risk that gives background on climate change. So there's a vulnerability assessment, which is incredibly comprehensive and talks about the threats, but they have things like tree species risks that help guide. If you wanted to know, I'm curious, like what species are predicted to do better or might suffer in climate change. They've made some projections. We don't know how they will actually fare, and I will say site specificity. So where that, on your woodlot, what kind of conditions you have that might play out differently, but they've given some projections here. I think I have, so this is what it looks like. They have, if I'd gone back here and I clicked on New England, it will put some resources down here, but this is what the handout looks like. And so it gives some, based on species and their model projections, what species do they think will likely decrease in population and which ones may increase. And again, these are all projections. I wouldn't necessarily go into your woodlot and say, oh, I'm only gonna, I'm gonna select only the species that this says will fare well. I think creating a good species diversity is the key for resilience. I think that's the best option. You kind of have, it's like having a portfolio stock with a lot of different stock options. You have all your bases covered, but it's nice to know, and this just helps you if you're in the woods, to keep an eye out for those species that maybe are projected to not do as well. So really the species that are projected to not do as well are kind of what we think of the colder species. So, things like black spruce, red spruce, white spruce, northern white cedar. But also there's a number of species here that have a lot of pests that might affect them. So there's a lot of different things that go on with this that are considered, but really the species that are projected to do well are the early successional species. So things like, black cherry, sweet birch, white ash, or mid-successional. And then the oaks are projected to do quite well because they're generally drought tolerant. But as we know, they have some pests, so that could impede their success. So, I would use these kind of this information as a guide. It's kind of informative to know what the science is saying, but also know that this is constantly changing and getting updated. And as we get more information and data, these may change. But so this is a great resource here. They have, one thing they have here too is adaptation workbook, which you can go through actually the steps and assess what the risks are to your forest, what sort of, they have some recommendations for climate change, smart silviculture, which is very helpful. So that's a great resource. They also, this is pretty technical, but if someone was very interested, this is from the U.S. Forest Service. This is the Climate Change Tree Atlas. So a lot of the information here is what informed the previous page I showed with the species that will do better or not do as well. And this is a model projection, but it's nice because it shows it on a map. And so this is basically, you can look, this is for sugar maple. This is where it currently is. And basically this is just a metric of how many stems there are and how big they are. So it's kind of a combination of trees, number of trees and size. And it shows, here we are in Vermont, we have pretty dark blue colors because we have a lot of sugar maple. It's a pretty big player in our forests. And then if you click onto projected habitats, this is modeled, you can see those colors got a lot less dark, which suggests that the habitat suitability will not be as favorable for sugar maple in the future. And basically that's, because it's a little bit more cold, loving species. It really likes deep snowpack. It has shallow root system. And so less snow in the winter could be problematic for it. But that's the projection You can kind of get into how they modeled this. There's a lot of data on here. We can kind of poke around and look at different species, what they're projecting. But again, these are models, and they're constantly improved over time. Yeah, so I have more here, but I can kind of send those to Lisa as a list. And this is something I do want to create on the FPR website, is a list of good resources where people can find that information and access it in one place. So that is something I'm planning on doing, is kind of updating what you can find on the FPR website in terms of climate change impacts, in terms of how to, what strategies are suggested for managing for climate change, managing for carbon, and all those kinds of things. So, yeah.
That's great. This looks like a great resource. Thanks for sharing that.
Yeah.
In thinking about some of these things that talked about, some of the trees that were going to do well, but then there might be some other concerns like insect or disease. Jeff is questioning the issue of worms. He's seeing fewer worms in his garden, and he's also heard about forest impacts from snake worms that are eating too much of the leaf litter. Have you heard anything in the changes of the worm population, or is there things that we need to still be concerned about?
I know that I haven't heard anything if there's changes in the worm population. That would be something I know. Jeff Gorez at UVM in the plant biology department, he researches this pretty extensively. But yes, so earthworms, European earthworm, all of our earthworms are not native. They were all wiped out, glaciation. And so we have European earthworms, and they've been around for a while. In fact, where I live is, a lot of our land here was agricultural, and I'm what seems like deep forest, but we have a stone wall and barbed wire you can find in the woods. And there are places I found earthworms. So they've been there for who knows how long. But we have a pretty good duff layer. So the concern is that those earthworms, they're great in your garden, churn over nutrients, but they churn over nutrients too fast in our forests, that our forests just aren't adapted to. So they basically create a nutrient load, and those nutrients actually can be leached out of the system. We get rainfall, and so they can get lost. And trees really rely on that influx of nutrients when the leaves fall and suck it back up. There are actually some nutrients trees take back so like a sugar maple in the fall when leaves turn beautiful orange and red. The tree's actually taking nutrients from those leaves, but it can't take everything. There's some nutrients that remain in the leaves, and the process is those leaves fall, decompose, and then they're available for the tree. So there is a really close tie here to that process. And when earthworms come around and change that process, it can mean that some of those really important nutrients like calcium, again, is incredibly important in our forest, get lost. The Asian crazy snake worm, boy, that's a newer one. And I think the concern is there that it's closer to the surface, I think, and it's just really voracious. I think it just kind of eats through stuff super fast. I don't know if there's any changes in the population. I know that Jeff Gorez at UVM has found it throughout the state, a lot of different places. So I don't, it's probably more ubiquitous than we know, but I don't know a ton about, how it's been changing over time, but it's a good thing to be thinking about. The concern is certainly that, again, like with this interacting effects I mentioned with gypsy moth, that potentially if we get a big drought and you also have a ton of earthworms at that site, maybe there'll be a stronger negative effect because of that.
Great, thanks. Harris would like to know a little bit about management and current use. So he knows you just started, but he wants to know what management practices related to mitigating climate change can be written into current use plans that will be approved by a county forester. He wants to know if you see practices that might not have been approved like maybe 10 years ago that might be approved today, or what recommendations you might have for landowners and foresters as they move forward.
Yeah, great question, Harris. That is something that I want to do soon, is provide some guidance for putting climate change intentionally into management plans. I think it is being considered by foresters, by consulting foresters. but it might not be. There's currently, the way the management plans are written, there's not a section that says that you have to identify climate change risks or threats. So I think that would be the first step, is having a section, when you're identifying what the regeneration is like on your site, what the forest health threats are. That would be a great spot for having, what do we think are going to be the main impacts from climate change? Like I said, maybe you have a steeper site. Maybe you have really, clay soils that aren't going to drain well. So if you get rain, it's just going to be muck. Or maybe you have, it's south facing, so it could be more prone to drought. Maybe, so there could be a lot of different things that you're looking at that are impacted by climate change. And so implicitly writing those in, and then certainly having some guidelines for different management techniques that we can do that would be help the forest be resilient to climate change, and maybe even help it adapt in the future to climate change. So think about that. I think a lot of those things those management techniques are actually being used, but they might not be specifically stated as climate change techniques. So things, like I said, increasing species diversity, being mindful of not having monoculture of a species, being mindful of regeneration, right? So not only identifying how much regeneration you have in a site, but when you actually do the operational treatment, being mindful not to impact that regeneration if it's something you want to maintain.
Can I follow up for a second? Lisa, is it okay if I follow up?
Oh, yeah.
Sure, Harris, go ahead.
I hear what you're saying, and all those practices sound great, and I can write those into a management plan for a landowner who is not in current use and really don't have to worry about the oversight. So the question is really for a current use plan that is, going to be approved by the county forester. That's the question, is, what will they approve? And I know you just started, so I'm not looking for an answer.
Right. So current use would have to, like, that gets a little bit bigger in that it's, a thing by legislative process to change that. So if it was something, that it was going to be a requirement in that, I'm not sure that would, if we're going to go that direction, or it'd be like a suggested, this is best practices to include climate change impacts and adaptation. And so there are a range of silvicultural treatments you can do, and it really depends on identifying those, what you think are going to be the impacts on your site. It's really, pretty site specific. There are some general things, right? So as I mentioned, like being mindful of water, slowing down, putting in bigger culverts. I know this is already being done. Thinking about bigger ditches, thinking about, is this going to have to be a summer harvest because we aren't sure that we're going to have deep enough, long enough snowpack in our winter to do a winter harvest. And what does that mean? That can increase the cost, that can increase the damage, but maybe that's done in the right way, it could actually benefit certain species over others. So there's a lot of different considerations. So a little bit, not quite at the level of having this into current use plans, but this is something that I've identified that I'd like to be able to provide some guidance for putting that in. But I don't think it'll be any different than what a county forester would approve. There's not going to be anything that's, a lot of these practices are really based, it's same as all, silviculture that's being done. It's ecological silviculture is based in the silvics of the species, the ecology. And so a lot of these climate change adaptation strategies are kind of offshoots of that work too. So there might be things like, okay, let's try to, we want to have more red oak on the site. Let's make some small gaps, maybe even planting acorns to promote this site into transitioning to more of an oaky site. That might be something you do, or it might be really, I identify that regeneration is a problem. I'm worried if emerald ash borer comes in, not going to have a future forest, but maybe increasing the structural diversity, size classes you have, so that if a disturbance comes in, you have resilience into the forest to consider that. So it's a lot of things that are already being done, but it would just be really with a climate framework or lens. So certainly that's going to be something that I would like to, with county foresters, provide some guidance. I'm not sure the details on how that would actually work out, but I'm happy to talk more with you, Harris, about that as I develop those.
Great, that sounds great. And those discussions are going to continue as this position develops, as we learn more about climate change or how it's changing as those models are refined. So I think that's a great question, Harris, that, you know, is going to continue on to the future. So thank you so much for bringing that forward. Liz wants to know if you can, and I think this is a great question, can you tell us the difference between carbon sequestration and carbon storage? Mm-hmm. I'm not sure I know, so please enlighten us.
Yeah, this is, you know, sometimes yeah, it's tough. We have the terminology. So, you know, trees, plants, but really trees is what we're talking about because they have long-term carbon storage is there in their leaves. They're taking in atmospheric CO2. They're, you know, with the sun's energy and some water, converting it to carbohydrates and sugars. And some of those carbohydrates, they take that carbon and the energy and store it into wood. So that's where the storage comes in. So the sequestration is really that annual intake of atmospheric carbon dioxide that is coming in. And that is about, you know, for our forests, on average, it's about a ton of carbon per acre, and that is about like 3.5 tons of carbon dioxide per acre that gets taken a year on average in our forests. It's quite a lot. And then that carbon
My bandwidth is low.
sheds branches, that carbon in that storage, that pool can go into other pools. So we also have the deadwood pool. So if that tree dies, that carbon then stays as carbon, but just transfers to another pool, the deadwood pool. It's still the forest carbon as a whole. And it can go into the leaf litter pool as the leaves fall. So now it's a different pool. And as those leaves and that dead wood decompose, it becomes the soil organic pool. And in each one of these other pools, besides the live wood, right, as those decompose, they're also releasing carbon dioxide. So there's a lot of, you know, carbon is not static in our forests. It's constantly what we call fluxing. So trees are actually releasing carbon dioxide when they break down their sugars. It's called cellular respiration, so they need the energy. So they're releasing carbon dioxide. As things decompose, they're releasing carbon dioxide. So it gets really confusing when we talk about carbon sequestration is really just live plants taking in carbon dioxide and storing it into a permanent spot, right? So making branches, making roots. The problem is that we have a lot of different, I just saw a note from Ethan, we have a lot of changes in those pools as things decompose. So really, carbon sequestration of our live trees is great, but also that net change of carbon storage, really that is what incorporates, do we have a lot of decomposition from dead trees? Do we have a lot of decomposition from leaf litter? How are those, you know, what is that, how is that changing over time? So right now what we're seeing is that our forests are taking in more and more, they're sequestering more and more carbon over time, which is great. And it's really coming into those live trees. Our trees are getting bigger, they're getting older, they're taking in more carbon and putting in stores. The other stores, soil, leaf litter, dead trees, remaining pretty constant, which is great. So that's, you know, there are fluctuations in there, but you know, over time, over the state of Vermont, our forests are pretty constant as far as that goes, which is great, because if we interrupted the soil, you know, this can happen with management, with really poor soil management. You can actually release that carbon, and so you can actually decrease the storage capacity of the soil over time. So it's great to see that we have constant storage in those other pools, and we're actually increasing the storage of the live trees because they're sequestering more and more and more every year. But again, back to the original point I made at the beginning, we have really our state's carbon storage and sequestration capacity is so contingent on the amount of forest we have. Because we have a per acre estimate, each forest type is going to act a little differently depending on the species, the age. But if we take that in aggregate, it's really so imperative that we have forest cover, because that's really what increases our carbon storage statewide, the amount we can sequester every year and take in. So it's a little bit complex, and maybe what Ethan was going to show, I was going to show this as well, is Tony D'Amato from UVM and Paul Cantanzaro made this great resource. I don't know if this is the same one you're sharing, Ethan, but this is called Forest Carbon, an Essential and Natural Solution for Climate Change. And what I really like about this resource is that it puts the information in a really concise, easy to understand way. And so, for example, they had this great this is summary of what I just talked about, the forest carbon pools, right? So storage of carbon in different pools, a little infographic that kind of explains the different pools. And they also have a great, I'll share this with Lisa. She doesn't have it on the Coverts website, but this is a really great, I love this diagram because it shows you how carbon sequestration changes over the age of a tree or the age of a forest, and how storage changes, right? So you can see here the brown is carbon storage over time, and the green is carbon sequestration. So we start off with a new forest, seedlings, saplings, pole timber, only sequestering, they're starting to sequester, but they're so small, they only sequester so much, take in. So they're taking in a lot. And really when they're this small saw timber size is when they're sequestering the most. They're growing super rapidly. They're competing with each other. They're trying to get to the sunlight, get to the resources. And so that's when sequestration is the highest. But you'll see the brown is still really light. So they're building up their carbon stores. An individual tree still doesn't store as much. As it gets bigger and bigger, you'll see the sequestration rate has slowed down to become steady, but the storage, because every year it's sequestering more and more carbon, that keeps adding to its storage capacity. And you get to these older trees, 300, 400 years old, and they store a ton of carbon. But they might not be sequestering at quite as a high rate as they did when they're young. So there's a little bit of a fine balance there. And then this also doesn't account for the carbon storage that goes into the wood products that are harvested if you do a harvest on this site. So that's another component to thinking about forest carbon, is if you send off veneer logs, you send off high-grade lumber to become furniture, often that can be in storage for many, many generations. We certainly have houses around here that are hundreds of years old that are storing some great carbon. So this is, I'll send this to, make sure Lisa can send this out. This is a great, really comprehensive document. I'm also looking at the time.
I was just going to say, we need to start wrapping up. This has been great, Allie, and we really, really appreciate you sharing.
Any other questions, Lisa?
There really aren't any other questions in the chat box. I have a few more, but we'll ask those another time. I'd love to host you again in the future. I think this was really interesting. I'd love for you to share those resources with me. What I'll do is, for those of you online, if you sign up for our e-news, what I'll do is I'll put those in the e-news, like highlighting we had this chat with Allie and here's some resources, or you can email me directly, lisa@vtcoverts.org, and I can send those to you as well. It's been a great morning having you, Allie. Anything else you want to add before we close out? All right, great. Well, thank you all for joining us. Vermont Coverts and Vermont Woodlands Association really enjoys bringing these programs to you. What you can do is sign up on either one of our websites for either one of our e-newses. I would do both. And you can donate to Coverts or join VW if that's something that those interest you. We really love having you on. As I said, next Friday, we're going to be moving our Coffee with the County Forester to 1 o'clock. We'll have Ethan Tapper and Sue Morse online talking about old growth forests. So we hope you'll join us then. All of these are recorded, so you can watch them again, or if you can't make it, you'll be able to watch it on our YouTube channel. And again, thank you so much for joining us. Have a great day.